Hey guys, welcome to How Strong is Your Magnet Lab.
What's up?
This is considered a big boy lab with experimental design. So make sure you are taking your time and actually understanding what you're doing here. Okay, so you need your laminated lab sheet.
Some are yellow, some are white.
Oh, the different colors.
Yeah.
Make sure it says How Strong is Your Magnet. And then you need the experimental design diagram. And then before we start, stop this video and read the procedures. Okay? Stop it, read it. All 9 steps. Okay, welcome back. You should have read your procedures. And now we're going to help you fill out this lab experimental design diagram together. We'll do this for the first 2 labs, and then we expect you to kind of become big kids. We'll have you do it on your own.
So in order to fill out the problem statement, we've already given you the DV, or the data variable. So you guys need to identify what the independent variable is. So what is it that you guys are going to be changing? If you didn't read your procedure, it's going to be hard for you to identify this.
Are we going to give it to them?
Yep.
Okay, or you can cheat and look right here, distance from the magnet. So your question, and forgive me if this is sloppy, this is not how I planned on writing. How is distance?
What is the effect of distance from a magnet on the strength of the magnetic force? Okay, so when you drop down to make your hypothesis, we've given you the IV and the DV, but you need to make it directional. So you need to say what direction you think the strength of the magnetic force is going to go. Do you think it's going to increase, decrease, or stay the same? And it's okay to have something different than those in your group.
Notice we are increasing the distance from the magnet. So you eventually will use your paper clips and you'll get them further away from the magnet. As you increase that distance, what's happening to magnetic force? Those are your 3 choices. Fill in the blank. Do you like how we bolded the if-then? Because Parkway says you have to have an if-then, and we will always look for those. Okay, next. Oh wait, so the independent variable, if you look at your hypothesis, we gave you a little cheat there.
And you should have already written this in your problem statement, so you have it twice on your sheet, so you should be able to pick this up really quickly now.
Remember when we highlighted our experimental design diagrams? I said it's very redundant, that means repetitive. You'll be writing distance from magnet over and over again, because that's your IV. It's so important.
So levels from the IV is something we talked about earlier. It's all the ways that you're going to change the IV from its original state. So remember, you have to have a minimum of 3 levels of the IV. For this experiment, you actually have 8.
So you're going to start off with 0 pieces of tape and then go all the way up to 7 pieces of tape. And then you'll start back over to 0. With your control, the control is the hardest one, remember? That's the one that nobody, I think, on the common assessment got for the pretest because it's so tricky. But it is your baseline. It's what you're going to compare the rest to. So we need to establish a baseline, and we're going to use our 0 pieces of tape to establish our baseline. And then we'll see as we add more distance how that affects the strength of the magnetic force.
So dependent variable, you have this already twice on your paper as well, but it's the strength of the magnetic force. Okay, so you guys are going to try to identify, is the magnet getting stronger or is the magnet getting weaker as the distance increases?
Okay, so if you need to pause this video to copy this down, feel free. Okay, constant conditions. So I kind of have a picture here of what you are doing, just to kind of remind you. You will need to list, let's say, 5 constant conditions. We'll give you, how do you want to give them?
Let's give them 3.
We'll give you 3. 1, 2, gosh, this line, 3. But you need 5 on your sheet. We're being nice. So I think, since we are hooking paper clips here, we need to be consistent with the size of the paper clips.
Yep.
And I'm going to do PC since my airliner's broken. I'm doing this by hand as a pain. So you please write out paperclip. I'll just write PC.
The other thing that we need to be consistent about is how we hang the paper clips.
So hanging method?
Yep.
Hanging period method. So why do you need to be consistent with that?
Well, because if you're going to hang all your paper clips from the hook, you can't have them attached to one another hanging downwards.
You don't want to chain. That
Right.
makes sense. And then if you're gentle the first time, you probably should be gentle the 12th time.
Exactly. Mm-hmm.
Okay, what else can we keep consistent?
Let's see. Oh, maybe the type of tape that we use when we add pieces
Yeah.
of tape.
We are going to add masking tape. Do you mind showing them what masking tape looks like?
This is masking tape, okay? You don't want to use one piece of masking tape and then switch to Scotch tape and then maybe switch to duct tape.
Or
It
that
need
wasabi
to be
tape, whatever that
right.
whatever that is.
The washi tape is what
Washi,
she means.
that's-
Wasabi is
wasabi.
with sushi.
I'm so with it.
So you need to come up with 2 more. Okay.
So think about the magnet. What do we need to keep the same about that? Think about the paper clips themselves. There might be more things we can keep the same. Or the tape itself.
Mm-hmm.
Okay. So here's our materials and procedures. There's a couple of materials we want to stand out for you. We're using again a circle magnet. You might have heard us call them donut magnets. It's the same difference. And then the ring stand. This is something we haven't used yet this year. The ring stand is this big old stand, has a big old pole with a base.
And you should have a clamp already attached to it. Okay. And ideally, your clamp will already have a donut magnet in it. Okay. So if it doesn't, let us know and we'll
help
get
you.
one in there for you.
So then you'll read each procedure. What we recommend that you do, if you're working by yourself, read the step, do it, read the step, do it. If you're working with a partner or a group, a small group, designate a reader to go through all those procedures with you. Any other procedures, things you want to talk about here?
Oh, yeah, let's take a look at the paper clip that you need to make sure that you have. You'll take a normal paper clip and you'll turn it in so that it has a hook. So that's where you'll hang all your paper clips onto. So this part will sit flush with the magnet. You can hang all your paper clips onto this one. Okay?
So here's the procedures. Continue on. Look how the tape is. The tape is nice and neat little squares of tape. So you just take the masking tape, break off a little square, and then you put it on the underside of the magnet.
And then you put your paper clip
On the tape.
on the tape.
And now this is level, this is 1 layer tape. So you just increase the distance. You're like, but seriously, Milla, seriously, Burkhart, that's not much. But it's still a distance. So you've increased it by something millimeters. It's something.
And you need to make sure when you hang your paper clip back on the magnet that it's not touching the clamp. If you have it touching the clamp on the underside, it increases the weight or the mass that the paper clip can hold.
Yep. Get you cheating. Okay, you will have a data table, so find us for the lovely data table. It looks like this. It's also on the page. You'll see that we do have a title that has the IB and DV in it. We have the distance and layers of tape here, and then you have the number of paper clips. We're not making them do multiple trials. We're not making you do multiple trials. You're welcome.
Oh, because we
You
Yep.
changed it.
used class results last time.
Yeah, that's okay. Just do 1 trial. And then your graph. I have my graph paper ready to out, so if you're in my class, you can grab a graph sheet, and I would set this up right now during the video. Do you have yours ready to go?
Yes.
Okay, so grab yourself a graph sheet. Remember the rules for graphing. For science, the 0 always goes in a corner. That's so important. It has to be in a corner. Label your axis. IB goes across, and where DV goes down. So I put the IB for you. Again, you have the right distance from magnet. Your unit is layers of tape. We could have increased it by putting paper there, put it in cardstock, or maybe have centimeters, but we decided to do layers of tape. The strength of magnetic force goes down the side on the y-axis, and we're measuring strength by using paper clips. During a different lab, we'll measure the strength of a magnet by using staples. But today, we're going to do paper clips.
When you guys go to fill in your title, remember it's the effect of the IV on the DV. And you can fill in those blanks. We've been over IV and DV enough in the video.
And I think it's the same exact title that your data table has. Voila! Okay, and Ms. Petruska has made us these cool signs talking about talking to your graph. Make sure your graph always has a title. You have your axes. You have the labels. And then you might need a key. For this lab, you don't need a key. You're just going to make a simple line graph. A line graph, not a bar graph. Okay, tips. Tip 1. Make sure your paperclip touches the tape, not the magnet. That'll be cheating because there might be a little red peeking out of your magnet. Tip 2.
Make sure that everything else you do is the same. So really the same person should be putting the paper clips on every single time to make sure that they're doing it with the same strength.
Tip 3. Use your common sense.
No, that's tough for some of you.
I know it is. Okay, when you are done and you did all the layers of tape, all 7, you will need to graph your results, which I showed you ahead of time. Write your conclusion.
And what kind of graph are we making here?
It's a line graph, so it's going to have dots and lines like that.
Because your IV is numbers, so 0 pieces of tape, 1 piece of tape, 2 pieces of tape.
Sounds like a song.
Then it's going to be a line graph, okay?
Okay, then you're going to write your conclusion. Your conclusion needs to have 3 pieces to it. You'll make your claim, which answers your question. So you will tell me, how does the distance affect the strength of magnetic force? You need to make a statement answering that. 2, you need to provide evidence. Evidence is numbers. So you have a data table that has numbers in it. Prove yourself with these numbers.
And then last, whether or not your hypothesis was supported. Remember, we don't use words like right or wrong or proven correct. We use supported or not supported.
That's it. And then you'll be ready for your lab quiz. I want to see your notebook before you take the first lab quiz.
I'll see yours too, so bring it to either one of us.
And then we will kind of pick it apart, have you tweak something, and you'll take the lab quiz. Lab quiz is about 5 questions. Lab quiz is basically, do you know your IV, do you know your DV, do you know your hypothesis, and so on. It's like, how do you do a good lab? Okay, if you have any questions, come see one of us. Adios.